Welcome. Today I'm going to talk to you about how to calculate the altitude that a projectile gets to. That's another way of saying the vertical displacement of a projectile. It's actually quite easy. And it's only based off of one aspect of the launch velocity. I want you to imagine for a moment that we have a launch velocity, and that launch velocity is at a certain angle. And this is something we've dealt with now a few times. A launch velocity with a certain angle. And from those two things, we should be able to figure out things like the horizontal component of the velocity and the vertical component of the velocity. Now, as you might imagine, the vertical component of the velocity is the one that dominates when we talk about how high something gets. And in fact, there's no difference between the vertical velocity component of the launch velocity and just a one-dimensional upward thrown ball with that velocity. So there's absolutely no difference. In fact, this horizontal velocity really has nothing to do with anything in the vertical motion. And so what we kind of do when we find these two components is we break up the motion into its two separate and independent parts. And so the vertical part is actually independent, and we can use it to calculate things like the height that the object gets to. We can also use it to calculate the time that the object spends in the air. So I'm going to treat this like a one-dimensional motion problem, just like we did during Unit 2. So here's our initial velocity right there, is this vertical part of the total launch velocity right there. And so we're only going to deal with that. And so we can kind of ignore everything else. We don't really care what happens with the horizontal part. And this is just the resultant between the two, so we're not concerned about that. Again, we only want to deal with this guy right here. That's all we have to deal with right now. So once we have that, that's our initial velocity. V sub 1 is equal to that. So that puts it in terms that we're familiar with from Unit 2. Now, if we want to find out how high something goes, what's the maximum altitude it gets to, we notice that there's this parabolic trajectory. And what ends up happening as the object goes through its parabolic arc here is that the vertical velocity gets smaller and smaller and smaller until it gets to be 0 right at the top, and then becomes negative and begins to get larger and larger and larger in the negative direction. And the reason for that throughout this whole time here is the fact that the gravitational acceleration is always at work and always acting in the downward direction as it goes through its path. It doesn't have anything to do with the horizontal, but it affects the vertical quite a bit. And so we want to make sure to remember that. So at this top point right here, right at that point, we have to remember that the velocity that the object has in the vertical direction, so this is our v sub 2 right here, is equal to 0. That's going to become crucial because that 0 speed sort of marks out that one moment in time. We can define where the projectile hits its highest point by the fact that it has 0 vertical speed at that point. So that's important. So now we have an initial velocity and we have a final velocity. And of course, as you've seen here, I drew these out here for a reason. These are all gravitational acceleration vectors. So we know what's causing the changes in the vertical velocity. And that, of course, is the acceleration that it experiences, which is the gravitational acceleration. Last but not least, we're trying to figure out how high it goes. And this height right here is another way of saying its displacement, or its vertical displacement, which is a delta y. So think about what we have here. We have an initial speed, we have a final speed, we have an acceleration, and we have a displacement. And we only have one formula that relates all four of those things together. And that, of course, is the no time motion formula, which we know of as 2.5, which is v2 squared equals v1 squared plus 2a delta x. Now I'm going to rewrite it in terms that we can use for this problem, and that is this v2 squared is equal to v1 squared plus 2g delta y. Now I can further change this because I know that v2 is the vertical velocity that it has right at the top, the highest point, which we know is 0. And so I know this is going to be 0 right here. v1 squared plus 2g delta y. Now, I'm trying to find how high up it goes, so I'm trying to find that little guy right there, that delta y. So I have to solve for delta y, and here's how I do it. I'm going to subtract this v1 squared from both sides. Okay, so v1 squared minus on this side. So it's a negative when I bring it over because I had to subtract it from both sides. And then it's going to be divided by the 2g right here that I had to divide away from this delta y. That's going to be equal to delta y right there. And that's going to tell us the height. Now again, this particular negative sign right there cancels out, which is a very convenient thing, right? It cancels out the negative sign that's in the little g right there. And so the height of the projectile is going to be found by this formula right here. Again, this is v1 squared divided by 2g. So hopefully that helps you. If you have any questions, please let me know. Thanks.